So today, I got two things to talk to you about. There's a chapter 11 we're going to talk about, but it's not very long, and there's another topic that came up last week, which is very important. And this is the class where I wanted to put it in, which is this report. I mentioned it briefly in my Saturday class, but this is the class where this is really important. So Kaspersky did a survey of CISOs, and that is very close to what you're going to be doing here. And I thought this was very interesting. So the first thing is, what is a CISO for anyway? And this is, I think, a very good question. If you'd asked these guys 6 years ago, are you going to get hacked? They'd say, no, we put up antivirus, we put up firewalls and unified threat management devices, and we won't get hacked. Now everyone is given up. Cybersecurity breaches are inevitable, 86%. They're all going to get hacked. There's nothing you can do, there's nothing you can buy, and no process you can do that will stop you from getting hacked. Now that appears to be the truth, but people aren't even lying to themselves about it anymore. And so now, if I was running the company, my question is, what are you guys for anyway? Why do I even hire you? What's the point? Maybe I should just not waste time on any security people then. Yeah.
My question is, what do the 14% believe? Why do they believe it?
Yeah, well, I think they have some discussion in the thing, but the article I read didn't go into much detail. But I mean, they apparently believe, probably, I would assume they believe the old-fashioned rule, that if you buy the latest device and more staff and you tune it up right, it'll save you. Which I think is utterly naive, and I think nobody really believes that anymore, except the people that are sticking to the old traditions. This, I think, is very common. There's a similar old tradition, which is that you will not let anyone teach attack at your school, and you will not let anybody have contests about attacking around your company because it's evil. The banks still believe this, and apparently Stanford still believes this. It's a lot of people do, that, you know, attack is evil and we should be only doing defense. Yeah.
Is APAC Asia Pacific?
Yeah, Asia Pacific, exactly, yeah. So here, when they say, what are the top risks? And number one is cloud computing and lines of business expanding. This is what we call VM sprawl. This is something cloud computing advocates, cloud computing is huge, but the number one concern of everybody, from amateurs to professionals, has always been security. If I put my data in the cloud, it's just going to get stolen, which is abundantly clear, especially the Amazon cloud, wide open bucket. Stuff gets stolen right out of the cloud all the time. So I think they're right to put this at number one. If you put your junk in the cloud, it is very likely it's going to get stolen. Then social networks, mobility, portable devices, legacy IT, these are all pretty hot. Notice how low insider threats are. Some people think insider threats should be higher, including the author of this article, but not very high, yeah.
How is it, does government want to lose in?
Government wants to what?
They want to look at your data.
Well, now that's a very interesting question. A lot of privacy advocates that we see in like the commercial press say you should be worried about the government searching you, but I think corporations are not worried about that at all. The fact is, even if it's your own server, the government can come to you with a search warrant, you have to hand over your stuff. If you're a business, and you have to hand over your stuff in response to a search order, just like your cloud provider does. So I don't think that is an issue for business people. This is something that for some reason they've got amateur home users pretending they can hide their stuff from the government by running their own server or something. And I really don't know what the point of that is. I think it's Snowden and stuff has just made people feel like they should try to hide from the government, which is pointless.
You can't say, that's my data.
No, you can't. You can't say it's your house. You can't say it's your money. You can't say anything against the government. The government has the right to impound all your stuff. There's court procedures. They can come to you with a court order and take your house and take your money and open your house and search through it and everything, you know. So I think protecting yourself from your government is not something you do with technical means. You do it by voting and stuff.
Well, you might say, this is privacy care.
Yeah, well, and you get privacy by passing a law protecting your privacy. But anyway, there's of course, what has come out because of the Snowden revelations is it's become clear that the government is vastly exceeding its legal limit, and they're spying on everybody with complete disregard for the law. And I've been reading the Puzzle Palace finally. They've been doing that for 100 years. Right starting around 1910, they've been spying on everything, completely ignoring the law, and they probably always will, but it's for purposes of national security, supposedly, although there are always abuses since they're not supervised. But it's a problem. But anyway, I think it's an interesting issue. And then there's what happens when you get a breach. And the main thing is reputational loss, perhaps financial loss, and so on. In fact, this is a huge problem with all justifying security, is you can't really see how much damage it would do if we got hacked. And I can't really say that anything I do is going to prevent the hack. So again, the top bosses said, why am I paying you at all? Why should I give you a raise? Why should I buy more? What's your return on investment? And they can't really say, you gave me $1 million, you'll result in $2 million saved. Not even close to that. So here's the top risks. Oh, that I think went the wrong way. All right. So then what is your role? And they say the main role is to assess and manage risks and manage technologies. So this is like what Richard Wu said at the club. He had this slide of the 100 companies selling you security gadgets. And this is the main thing the CISO does is buy some of that stuff and deploy it and monitor it and decide whether to buy the next one. And that's pretty much what you do, is figure out which of all that junk you're going to standardize on and keep it going. So what's the pressure? Complex IT architectures, I have to agree, and PII, like we were saying, and then all these attacks and stuff, but I'd say the complexity is the number one problem. You have so many servers and so many clients and so many people running around with cell phones and everything, and so many security products you have purchased that each have huge problems and limitations, and you're trying to somehow keep it all under control. When it's madness. It would be so much nicer if it was something like just a Windows domain and everybody had to use their work computer that was on a desk connected with a wire and you could control it all from Dane controller. That's the way it was like 15 years ago. That was a much simpler world than where we are now. And so what are the qualifications? Maybe experience. More than half of them have more than 5 years of experience. This is what all the students find out. If you want to get jobs, it's hard to find any jobs that don't require experience, which is very frustrating to new people. You have to work as an intern to get some experience, and they care about experience a lot more than education or credentials of other type. Experience is the only thing that really matters. The Netflix security team came and gave a talk here, and the guy said, "Do you want our students interns?" She said, "No." "Do you want our graduates?" She said, "No. We don't touch anybody with less than 5 years of real experience because you don't learn anything in any training program that's worth a damn. The only place you'll learn anything is working at real companies. Those are the only people who actually know how to write secure code. Because there is no training program anywhere and no certificate or credential anywhere that means you can actually write secure code. That's what he said, and that was only a couple of years ago. As far as I know, nothing has changed. Anyway, and they mostly have a master's degree. 68% of them have a master's degree. A doctorate is nuts. Almost nobody would do that. The doctorates are not for people who work. They're just for people who teach. And apparently a bachelor's is not considered to be enough here. I know the standard, a lot of people, is a master's in information security. So apparently if you're going to be a CISO, which is a very high position, you're expected to have a master's degree. Now, to be fair, probably they didn't get a master's degree first. They probably got at the company in a lower role, and then they took like night classes to get a master's while they were there. And the company might have paid for it. That would be normal. But they do end up with a master's. They have to have that level of comprehension and that level of maturity. Because as you probably know, most of what happens in school is not actually learning the content of the classes. It's learning how to navigate a cruel, abusive, bureaucratic structure. Meet deadlines, fill out forms, obey stupid rules. And that is what you need in corporation, is that ability to handle the bureaucracy and the management.
I noticed that speaker had a bachelor's in psychology, I think.
Could have been, yeah. No, but a lot of
Yeah,
people,
you said that.
a lot of leaders here have degrees in other things like poetry and classics and stuff.
But I mean, what about CISOs? Don't they have English degrees, fine arts, and all that stuff?
I don't think I have a slide about it. I don't really know, but I would imagine, yeah. But they probably have a master's in information security,
Oh, yeah.
I would think.
But I mean,
Then the industry search, CISSP is the main one. This ISO 27000, I thought that was the company, not the person that got that cert. I'm not really sure. But anyway, CISSP and CISM are the main thing. And more than half of them have it, but that means about half of them don't have any industry certs. A lot of people question the value of industry certs, but the CISSP is the main one that gets you somewhere, in as far as any cert does. And so what is the performance? Since they can't stop the hacks, and you can't say how much money they saved you, then what exactly is performance? And they say speed of incident response handling is the main thing they can do. This is, I think, is not because it's the most important thing. This is probably the only thing they can actually measure about what they do. So that's it. And then in compliance, being in compliance, reduction of incidents, overall number of incidents. And you know, this looks to me very much like it is not the most important stuff. It is just the only stuff you can measure. But anyway, that's where it is. That's why your textbook in this class is all full of IR speed as a measure of your maturity. And it is apparently the expected measure of maturity. So what are your skills? IT, tech mostly, but then business number 2, and empathy. Number 3, then technical expertise and other things. This is why I have a lot of students that are in business and they want to take some tech, or they're in tech and they know a lot of business or legal, and I say, you're in a good place. Straight up tech people are pretty much replaceable like light bulbs. You can just hire another tech, they come and go, they don't get paid very much, they don't get promoted very fast or very far. And the straight up management people with an MBA and no tech are not that valuable either. What you need is people that can do them both. And there aren't enough of them because it is two different human personalities. There are people who want to show up on time and wear a suit and be neat and polite, and then there's people who can't be bothered with any of that because they have to hack all night and play video games and stuff. And usually the two are two different groups of people. And if you can somehow bridge that gap, they really need you. Someone who can be polite and dignified and dress well and talk to the CISO respectfully and also deal with those crazy hackers and somehow keep them on track. And you have to understand them. And I mean, that's always been my position here, I'm the guy that protects the hackers. My hackers are always so crazy that all the authority figures just want them to get rid of them. And that's the way it has always been. And it's a problem. And I try to protect them from the worst of the management and try to guide them into being more mature and responsible, which is not easy. It is the opposite of what they are. My most brilliant technical student in years keeps on getting thrown out of the country because he can't even be bothered to show up on time to fill out the immigration forms. He's always like a year late filling out the forms and finds some miraculous exception, another miraculous exception. Everybody says, why don't you just do it on time? He says, oh, I had to do this encryption for like a month. Post this. And I understand, I'm the same way. But that's what happens. It's so much more fun to play with technology that all this boring stuff just isn't worth the bother, even when it's really important to do that boring stuff. Like I kept forgetting to pay the rent, The reason why I'm in this position because I used to be that guy. The only difference between me and my crazy students is that I'm older. I'm not any wiser. After you get older, it's a little easier to do the boring stuff.
Did you still do your tax on the last day before the extension deadline?
I did, yes. That's right, which is better. I tried ignoring my taxes completely for like 3 years, and they get real rude, They get pushy, they send you scary letters, they hunt you down. They really annoy, so it motivated me to pay a little more attention to it, but anyway. So then there's hiring. So how easy is it to hire people? What's your problem? And the problem is to get people that are sharp. Malware analysts, cloud security specialists, network security, risk managers, and pen testers, and IR people. They can't find enough skilled people in these professions. These professions are hard, and there isn't much in the way of training for them, so it's just interesting, Those are the people they really can't find. And are your budget going to increase or decrease? And the answer is it's going to increase. Everybody's spending more and more and more on security, which is kind of nuts, but that's where we're at. We are so ineffective that they hire more and more of us. So here's the most difficult type of attack: ransomware, phishing, and malware. It's the hardest stuff. The rest of them are somewhat easier. Ransomware, they're certainly very afraid of. It's surprising to me because it seems to me like ransomware is trivial to prevent. Microsoft's built it into Windows now. There's a simple rule to put it in your IDS. Your host intrusion detection system should easily be able to see it. If anything suddenly starts writing over many files, you could just block it. Anyway, but apparently there is not a common, easy to deploy solution that really works yet. Yeah.
Yeah, I feel like internal threats and social engineering should be way higher.
Yes, you would think so.
Should be down there.
Yeah, well, it's an interesting, I know, quite a few things are surprising. That's why I think this is important. It's very interesting. And so attribution. What's the biggest risk? And they think financially motivated and malicious insider. And then politically motivated groups are way down. I really haven't seen them in a long time. But that seems pretty reasonable to me. And so without a clear ROI, you do not have a clear return on investment. You cannot tell the board of directors that $1 million spent on me will result in $2 million of value back to you. Not even close. You can't even make a bullshit pie chart and sell that. So what do? You have number of breaches, you scare people. That's why he said, this is really annoying, this is like FUD. You tell them about all these other people that got hurt in mandatory regulations and the possible impact of attacks. That's all you can do, is try to scare them with how bad a hack would be and therefore give me more money, which is where we're at. But that's the opposite of logical business. You're supposed to calculate, how much do I pay on this? How much do I get back? And I spend money on it because it's returning something, and I measure at the end of the quarter how much money I got and decide whether to spend more, and we're nowhere near there. This is why for a decade or more I've heard of security metrics. People say we ought to have some kind of measurement of security. Your security is a 5. If you buy this, it will be a 6, and that will save you this much money. That's not, is that asking too much? Apparently that is asking too much. But in the grand scheme of things, you would think, when we get there, then we'll be a science. Right now, it's just an art. Yeah.
So I'm thinking, 2, 5, and 6 would be the most significant ones in terms of business, right? Because they would want to know, since you can't put a number on.
Well, these are the ones that try to put money on it. This is legal requirements. That's certainly an issue. And you have these breaches report. I think realistically, the only thing that actually matters is what I do when I'm notifying companies. It just seems to be humiliation. They say, look, you don't want to be the one on the front page, latest company that got hacked, and you will be if you don't beef up. So that's all. It's reputation, really, this intangible thing. Of course, to be fair, a lot of business is done that way. I know Google came in and wiped out print media because before Google took over advertising, there was a belief based on nothing that if your commercials looked really flashy and had models dancing around smoking cigarettes, then people would really love that and buy more cigarettes or Pepsi or something. And they spent a lot of money making those slick commercials, and they were never able to really prove that they sold more stuff based on that. But there was a strong belief that it was worth paying a ton of money to have these beautiful commercials everywhere. And Google's the one that moved in and said, we can actually measure how many people click on the ad, how many people buy the thing. We can make it scientific instead of an art. And that wiped out all the other forms of media that had been selling this kind of hand-waving general idea that, buying the $1 million firewall has got to be better than buying the $500,000 firewall. It must be making your company better. In some way we can't really explain. This is where we're at. But I feel like it can't stay this way forever. We have to make this more scientific. But so far, we can't even decide how much damage a breach does. The amount of damage is somewhere between $200 per record and 50 cents per record. There are examples of both of those happening. That's a really big range. This is very far from a science when you can't even decide how valuable your fundamental product is within a factor of 100. Then we're really an art and not science here. So who else do you cooperate with? IT, legal, C-suite, HR? Everybody. That's what the message of this textbook is saying. You think it's an IT problem? It's not. You think it's a business problem? It's not. It's everything. Every part of your company is involved in your cybersecurity profile, and they need to be. And you need to get over pretending that you can have one little group of people make decisions. You've got to build a coalition. And that's why I say, the people that can mix business and IT are the ones we need. Anyway, so here's new technologies. AI is the huge one. AI is everywhere. That's why I was really glad to get the last visiting speaker to talk about this. AI is already here. It is going to be everywhere. We're all going to be using it. And cloud-based stuff, blockchain, I don't know what the hell. Well, blockchain is getting so much hype and so little value. But anyway, it goes on. Then you got, however, look at this stuff. If you think blockchain is bullshit, look at this stuff. Cognitive machine learning, predictive, quantum cryptography. Everything below about number 2 is all bullshit here. But that's usually the case with new technology. There are things that are getting a lot of hype, and people don't know what it means. Dilbert's boss is always full of this. I saw a conference. We have to have blockchain by next week. And he's like, dude. Yeah.
So you don't think quantum cryptography will work?
No. Quantum cryptography has been around for about 10 years. And it does work, but it does not offer any real value over normal cryptography. It's a stunt. It's a way of distributing keys. One thing about it is it's not mathematical. You distribute the keys, by sending one photon at a time, and you know that no one else in the middle got it. It's kind of a cute stunt, and there are some deployments in a few places, but it turns out to be more expensive and not really any better. It's kind of cute that you can do it, but no, it's not important.
Isn't it good for cracking or
No,
potentially?
that's quantum computing, which is not even listed at all.
I didn't see that.
Yeah, this is quantum key distribution, is what quantum cryptography is. And all that is you have a AES key, and you send it from one end of the wire to another, one photon at a time, so nobody read it in the middle, because if they read it, they could not reproduce it. And so you can deliver a secret key with complete assurance that it was not intercepted by a third party, and you do not need to have public key encryption for that. So in a grand scheme of things, way of thinking, it ends the need for this RSA kind of one-way function. So if you had quantum computers and they broke all possible public key systems, you could throw them away and use quantum key distribution instead. But there's no need for that. There are already post-quantum schemes being developed. And so I think in practice, mathematical cryptography will be very good and much cheaper. So it remains a stunt. It's a technology, it's kind of cool. There may be some case in which you need to use it, but most of the time I think the purely math-based ones are just good enough and cheaper. Anyway, so I thought that was worth going through in this class. Lots of interesting information. And there's a link about 3 or 4 days ago on my website of Kaspersky's report. You can download it and look at it. But I thought it might be important to you folks not only to know the role, but also to think about your career and where you want to go and stuff. Anyway, so now we're down to the usual stuff, which is analysis methodology. This is basic detective work. So how do you hunt for a problem on your network? And so here's the general category. You have to define your objectives. This is a big deal. I know I used to teach fiber optics. I was surprised to learn that the salesman is a teacher, because your customer typically does not understand the technology. They don't even know how to ask for what they want. They need you to tell them what they need and help them understand why they need that, which is kind of nuts, but that's where it is. So the same thing here. You have to help you manage objectives, then get your data, then convert your data, analyze, and see what you can prove. The objectives are typically come to you in a fuzzy, ill-formed manner that cannot be answered. Like, did we get hacked? I said, well, we need to be more clear about this. This is why there are idiots out there that say this product is 100% secure. And anytime they say that, they're an idiot, because there's nothing 100% secure anywhere. There's nothing you could buy. There's no process that's 100% secure. And anybody that says that is an idiot, or they're lying, or both. And so you have experts avoid saying stupid things like that. You have to say something that is reasonable and can be proven. So you have to determine what you're trying to accomplish and whether you can accomplish it and how long it will take. So you figure out what you need, who wants the answer, and what do they plan to do with them. One common example from the world of availability is if you ask your boss how much availability we need, he said, I need it to stay up 100% of the time. And you have to say, no, you can't have that. That is a stupid thing. Don't ask for that. You have to be more polite than that. But the fact is, nobody can do that. Google can't do that. The government can't do that. And Yahoo can't do that. Nobody can keep anything up 100% of the time. All you can ever get is 99.9, 99.9, 99.999. And the third one of those already costs like 10 times more. Each one of those nines costs a factor 10 more. So when you put it that way, you have to explain it to them that perfection is not an option. But that's, of course, what they'll ask. I want it to stay up. I thought that's what you guys were for. So somebody has to be the boss who's going to define these objectives, and it has to be clear who the leader is, or people will wander off doing stupid things. And you cannot prove a negative. So you cannot prove that a server is not compromised. The server is all full of stuff. You don't know what it all is. You can never be 100% sure that none of that stuff on there is malicious. So you have to have more careful requirements. You can look for certain indicators of compromise. You can prove that certain malware you specify is not on there. You can state an opinion that it doesn't appear to be compromised. Your test shows it reasonably clean, and this is the kind of thing you do in court. It's never perfect, but you can make a well-informed opinion. And so here's realistic questions. Is malware present? That's not clear, but you can say if there's a particular piece of malware on there, that you can answer pretty easily. So look at this thing and find out what's going on. It's too hard. You have to have more clear things. Find out something. This is the kind of thing you'll do in e-discovery. My student that went into e-discovery, he's now coming back. He wants to hire more of us. He'll be giving a talk. We're working out the details. But that's Mahmood. He wants to hire more students to do forensics and e-discovery. It's a big field. And there you have a clear mandate. There's a lawsuit about this topic from this date to this date. Go find every file about that topic and give it to us to hand over as evidence. That's a reasonable thing to do. That can be done, and you have to do that. So what you have to do, since the people that are asking you for answers are not very clear on what is possible, you have to go back and forth until they understand what do you really need and how do I get that. Since I cannot give you exactly what you asked for, and you probably don't know how to ask for exactly what you need to talk about what do we really need. So that's the game. You go back and forth, and the two of you sort of work together defining the objectives. So this means you have to understand your data, and the fundamental problem here is the same fundamental problem that Google faces. You have way too much data, and it's all in different incompatible formats sprayed all over the place. And that's the problem. That's why all of these unified threat systems, all these log monitoring tools and such are really hard to use, because the problem is just really hard. You don't have all the data in a nice, neat table in one place that you can look through. You've got desktops, laptops with hard drives, external storage, and cloud storage all over the place. You've got servers all over the place, all running different kinds of stuff, all in different physical locations, and they're all using external storage solutions like SANs and such. And you've got mobile devices all over the place, phones and flash sticks, all these things flying around with data on them. And you've got all kinds of these things, USBs, network attack storage. There's just data in all these devices sprayed all over the place, and there's no simple way to get it off one of them. Each one of them is separate. And then you got your network devices that are not intended to store data. You won't find people's Word documents on these, but you will find important information for incident response on the firewalls, switches, and routers in their logs and the routing tables and such. And you need to get that, and even in the configuration, if people are hacking in and changing the configuration. And then you got these cloud services. This is like, say, the CISOs are very worried about the cloud, because now you've got your data off-site in somebody else's hands where you can't even image it or get your hands on it at all. So, and you've got important stuff up there more and more as you outsource and put your stuff in the cloud. You know, now if you want a forensic image of your server, you probably can't get one at all, because it's really just a virtual server on a SAN shared with 100 other customers, and there's no way to image it even if you paid them a lot of money. There's just no, it's just not an option. So, and then you got your backups. Your backups are all over the place too. So, and your disaster recovery, you also have that, and it is different than backup. I used to be confused about this. Your backups are there in case you accidentally delete a file, you can get it back. But your disaster recovery is in case the whole building burns down. And it's typically similar to backup, but it's typically a different solution running through a different network and such. That's how it goes. And often these things are all cloud-based, like Carbonite or Mozy, backing up and making disaster recovery copies of things over the internet. So it's stored all over the place where you probably can't really get it in any clear way. So here's types of evidence. You got operating system logs, like the registry, and then you got application data, user data, and network data. So your operating system uses a file system on its storage device. The main ones are NTFS and HFS. JHFS now, that's the Apple one. NTFS is the Microsoft one. Linux uses ext3 or ext4 mostly, although it has about a dozen other ones that are used occasionally. And so that's file system data. Yeah.
What is it? Would you say it's HFS?
HFS is high performance file system, but then there was HFS Plus, and then there was JHFS, which is journaling, and I think we're now up to JHFS Plus, and we might even be a step beyond that to whatever. They keep, you know, just like everybody.
What OS do they go to?
Oh, it's all Apple. Apple uses all of them, yeah. Those are all the Apple file systems.
Yes.
And they're all very similar to each other, like all the versions of NTFS. And then you got your state information, open network ports and running processes on one machine, and then the logs in the OS and other things the OS stores, which we'll be going through in a lot of detail in a couple chapters. I put it up into 3 whole lectures about Windows. 1 whole lecture just on the registry. Windows stores an incredible amount of data about everything you do all over the place. That's why if you plan to do something on a Windows machine and then lie about it, you're screwed. It's got 100 records kept everywhere, unless you grind the machine up in a chipper. There's no way you're ever going to be able to really hide from a forensic examiner what you did on a Windows machine. It is keeping so many records of every damn thing you do that you're never going to find them all, and downloading some kind of privacy extension to your browser is not going to get them. All that will do is stop complete amateurs like your kids that will look in like the recently opened documents in the browser history. It'll keep it out of there, but there's 100 other registers of everything that's gone on in there. Anyway, and the other OSs do it too, and none of it do deliberately. They are not deliberately tracking. It just turns out that there's a whole lot of features that require keeping track of what's happening. So Unix has a syslog, and Apple has plist, and Microsoft Windows has a ton of personalization features to make it easier to use that require keeping track of everything you've been doing, so they can pop menus up and put the more frequently used items on top. So in general, all your file systems have to have some kind of allocation unit. They have to have some way of indicating that a block of data has been used and how it fits in with the other blocks of data to make a file. They got to have active files that are in use, and they have to have some system to mark deleted files, because all of them find it to be too much bother to actually clean blocks when you're done with them. So they just mark them available and reuse them later. They got to have some kind of timestamps and some kind of partition tables to split the disk up into segments. And there are different ones. NTFS has a bunch of timestamps and these alternate data streams. UFS has inodes in Linux, which is where it stores in metadata about files. HFS has these things called resource forks, and the older FAT stuff had this file allocation table thing with the 8.3 file name. Those are the details for each particular one, which are the details of how they implement those general concepts. But they all have some way to restore a file name, keep track of what's in use and what isn't, have some kind of timestamp on it, and some kind of access control list on it, except for the really old stuff like that. Brian Carrier is the king of this. He wrote this book, it was very detailed. I went through it with the classes. I used to do it in my forensic classes here, and I decided it was too painful. But he really, I have a project, I don't know if Alan's still using it, where you actually fix a broken NTFS file stream, or bit by bit hex editor, which is the kind of thing you do here. You can do that. You can reconstruct broken file streams, but it is pretty damn picky, and realistically, I quit teaching at that level because in practice, you just get a tool like Encase and it does it for you. It's really not that important. So I'm trying to move away from the write down in the bits stuff when it's not appropriate. It's appropriate for exploit development, but it's not really appropriate for this level. Anyway, so then you got all the records kept within applications, like your browser cache, your web server logs, the database remembering things, and all the preferences and contacts and so on. These are all files and registry keys and stuff created by applications, and often even when people uninstall applications, some of this stuff persists. And then there's, of course, all the data created by users, Word documents, spreadsheets, email, and all that jazz. This is not only on their machine, it's on all kinds of other things, like their Dropbox, the company server, and the email server all over the place. There was a fun presentation a few years ago from the company that brought VMware, EMC, and they said, suppose somebody takes their camera, their phone, and they take a picture of something. So now they have a picture, maybe 10 megabytes. They said, if you watch what happens to that picture, it ends up having 80 copies of it, because there's a copy in iCloud, then they email it to somebody, there's a copy on this server, then there's a backup of that server, then it goes over here on a SAN, and there's 3 backup copies kept in the cloud. You know, by the time that's why data grows so fast. Everything you make, by the time you share it on Twitter and email it to somebody, there's 80 copies of it. So the number of storage created is huge. The number of hard drives running at large companies to keep track of all the data we're creating is monstrous. And that's what EMC's primary business is that enterprise class storage stuff. Anyway, then you got all your servers, DHCP, DNS, your proxy servers, your network flow monitoring systems, your IDSs and firewalls. They're all doing things, and they're all keeping logs, and they all have information in RAM about the current processes. And if you want to access the data, the problem is, in its raw form, it has many different formats. It could be encrypted, rest or encoded. If it's encrypted, you're pretty much screwed. That is really painful to decrypt it. This is, of course, why people like the EFF do tell people with privacy, you should make your own email server, use special things like Signal, because the point is it irritates the cops and the government. Now they can't just scan everybody's email. Now they have to work really hard to get each person's email, so they're closer to actually obeying the Fourth Amendment, where they'd actually like to have probable cause before they went into your stuff, because they couldn't just easily hoover up everything. And that's, if they could get everybody to use encrypted stuff, that would certainly make it difficult for the government to do bulk data collection. But it would mean that everybody somehow had to manage those keys. And that is the real reason why it never gets popular. Anyway, so you've got all these things, and your raw data might be in any of these formats, and it might be on something that is to some extent broken, like a hard drive with errors or a database with defects. So again, you got to find out what you've got. If you get the data from somebody else, you have to be smart enough to ask careful questions. I started a lawsuit myself when I was back in the escrow agency, because I got a database of people, and there were like 300 people on a database, and there were 12 people that were not supposed to get this mailing by court order, but the person who sent it to me just took an Excel spreadsheet of all 300 people, and then they right-clicked and hid the columns, hid the rows of the ones I was not supposed to mail to. And they didn't give me a total. 251 people, not 261 people, so I had no way to know that when I ran a mail merge, it merged them all, including the hidden ones. And I mailed to all of them, and next week they said, you broke the court order, you mailed to the people you were not supposed to mail to, there's another whole lawsuit suing us for doing that. And you know, so I didn't get fired again, because I never lied. And I say, what did you do? Here's what I did. They said, well, yeah, it was obeying our procedures. We're going to have to change our procedures now. So our procedures were now, you will never accept any data from anybody without a total of exactly how many records and how many dollar amount, so we can verify. We didn't require that previously, and we discovered that you need to do that. So
Couldn't you just have unhidden the columns even before you merged?
well, I didn't even know it was hidden. I just converted it. I just merged it. Merge didn't pay attention to hiding. Hiding only affects if you're going to print it out, which I never did. I just connected it to Microsoft Word, did the mail merge, got a pile of letters, mailed them out, job done. Everything's fine. Next week, they all start yelling at me. Well, you know, what did you do? I said, well, I did what I was supposed to do. And I said, well, apparently you did. So we got to work on that. So my boss was pretty good. You know, he didn't punish me when I'd actually done what I was supposed to do, even when it was the wrong thing. They never got mad at me for going to them and saying, I did this bad thing. Because I didn't hide it. If you lied to them, then they would fire you, which is reasonable. Anyway, so then you got disk images. Now, your disk might be encrypted with BitLocker or something. I say most people just give up at that point. But it could be something else, like from a RAID or something. There are 3 images typically used for hard drive images. The most popular by far is Expert Witness. People think it's Encase because Encase made this their default format. The reason it's popular is because it's compressed. So if I image like a 500 gig hard drive, the image might only be like 20 gigs because it zips them and puts them in files. These others typically don't, which is very annoying. A 500 gig file to fly all around. DD is just a raw image, bit by bit, not a zipped. I would think you would just zip it, but for some reason that's not traditional. So, and then there's, if you have a virtual disk, which is increasingly the issue, you can just get a copy of the virtual hard drive. It's stored in a VMDK file, or if you're using open source virtualization, you can export it into an OVF, open virtual format. And then you got an image of the storage from the virtual drive, and all these things can be turned back into, with the right tools, just DD files, which is just bit by bit what's on the disk. And you can just read the strings in it directly and put the files back together. Encase can handle all 3 directly. FTK Imager can create and convert between them. They're all mathematically identical. You can convert any one of them to any other. It's just like a zip file, an unzipped version of the file. Linux typically wants just straight DD files because the people that make the tools don't feel like bothering to include converters and stuff. They say, before you give it to us, turn it into a raw image. And the data may be encoded any number of ways. So this is, the password is solved crime. This here is base 64. Base 64, you take every character and turn it into ASCII, which is 8 bits, and then you take 6 bits at a time and put them in here. So every 3 characters turns into 4 characters up here. So THE turns into GGHL. This is the first 6 bits in T, this is the last 2 bits in T, and the first 4 bits in H. And so it goes.
So
yeah.
is that why they use it in transmitting data? Because it's,
Oh, they use it because they use it because of email. Email was an ASCII only medium, and ASCII actually only uses 7 bits out of the 8. The characters only go up to 127. The 8th bit is for parity, so ASCII cannot transmit a binary file because 1 out of every 8 bits is lost. So you have to somehow encode a binary file in some other language to send it through email, and that's what base 64 was for.
so you get one base 64 byte per email byte?
No, you get 4 base 64 characters for every 3 input characters. Because 3 input characters, you have 8 bits here for the first character,
Yeah,
and
you
another 8 bits,
bytes
and another 8 bits. So
7.
that's 24. So you cut it off 6 at a time, you get 4 chunks. So base 64 has got 4 characters for 3 bytes of input. And that now you can send it through a ASCII only medium because these really only have 6 bits of data in each one. So they only use uppercase letters, lowercase letters, numbers, which is a total of 62, and 2 more punctuation marks, typically like plus and slash, I think.
So they're used because so they're limited to email?
Well, it's a way of converting a binary thing into ASCII and then back. There's another one was Udo encode was another way to do it. But base 64 became the most common one. And now a lot of people use it because they think it is hiding data, because you take something readable and you turn it into that garbage. So people think they've now hidden that image. This is why I'm going to be giving a talk to a club about this. This is obfuscation. Many people think this is encryption. It is not. It is just making it hard to read. But if you know the trick, it comes right out. It's not actually hidden in any good way. So here's UU encoding is the other way, where you again have just taken it and turned it in. I don't know quite how it works, but UU encoding was the other way, to move binary files through email. And then you can make an MD5 hash, which is hexadecimal and always the same length. And at one time, people liked to say that this was irreversible, but in practice, it's not that irreversible at all, not anymore. You can do hash cracking quite efficiently. In principle, from a mathematical purist point of view, MD5 destroys information and cannot be reversed, but for short things like passwords, in practice, it can frequently be reversed by just trying a huge table of passwords until you find it. And then here's one example. If you were to take this kind of data, like you might have a log that has a binary output, and so it puts out data like this, like what we see if a dump from a hex viewer, where it actually puts out the hex digits here, and then the ASCII over here, and then a carriage return, and now more stuff here. Now if you actually look for a credit card number, you're not going to find the whole number on one line. You'll find part of it here, and then junk in the middle, and part of it here. So just doing a grep for a pattern of 16 digits will miss some of these, because the way the data came in, it was formatted in a way that broke it. I was involved in a huge lawsuit with maybe 50 million people, and I was not the main person running that lawsuit, but they asked me in to review it when they were about to mail out the checks. And I noticed that there was a pattern of undelivered mail, that every 256th letter in the original database, 20 million, or every 256th letter had been returned undelivered. So I looked at them, and they all had garbled addresses. Like they'd have the last name in where the name of the street goes, and the city number in where the zip code was, and the state missing completely or something. So that all came, and nobody noticed. It was because of an input like this. Every 256 lines had like an extra comma in it and broke the pattern. So it broke the import process, and nobody had noticed. And I said, dude, I think you got a problem with your payout.
But I don't see a carriage return there. Is there?
Oh, there is.
7?
It's implied. This goes to the end, then there's a carriage return. So if you actually look for the string, the actual string here is BEGI000. That's what you'd find with grep.
But wouldn't it show up in the hex?
If you-
at the end of
yes.
the hex, the 16th hex, right?
Well, like this one here, where you have, this one here, you have like 6 or 7 digits here, and another 6 or 7 digits here. So if you made a grep that is 16 digits, it won't match here, and it won't match here, and it won't match here. There's no place where the 16 are nicely together. They're broken in the middle with a whole bunch of...
Is wouldn't I see that the carriage return or the line feed
Yeah.
on the rightmost?
Yeah, so
character?
you'll see 547, 1236 carriage return, then 000040, then 39, then 38. The rest of that credit card number is all the way over here with the
Where do you
last.
see the carriage return?
It's here. It's implied. There's a carriage return. That's why it goes on the next line instead of having the 0 right after this 6.
So you don't see it on the hex.
If you saw this in a hex viewer like HXD, then you wouldn't see it at all. The HXD would actually see the raw data. And if you searched inside HXD, you'd be fine. But if you printed out this result into a text file and looked at it with Notepad, then you wouldn't see it. And that's what he's saying. That's the way you often get log data. It's already been put in a text file and broken with other carriage returns and formatting, and now you can't search for pattern easily in it anymore. So what you have to do is pre-process it with something that'll break it up and reconstruct it back into the original file. Anyway, then of course there's all the problems with times and dates, and characters and money. If the clocks aren't synchronized, if you cross time zones, if you cross international boundaries, and of course stinking daylight savings time, which is endless headaches for everybody. Some places even have it off by half an hour instead of an hour just to make you cry. So, anyway.
And on the ballot?
It's on the
Yeah,
ballot.
it's on the ballot. From viewpoint of forensic scientists, it would be great if they would just get rid of it. We have enough trouble anyway, but I don't think we're the main stakeholders in that argument. Why aren't we using metric? Why are we using feet and inches? When Britain gave them up like 2 or 3 decades ago, because yes, we're like a cargo cult worshiping a god that even the people that invented it have abandoned. It's nuts. Anyway,
It's true.
we're using it because some ancient king had a foot of this size, when even the British don't care about that anymore, but we care for some unknown reason. Anyway, so then you can have examples here. So you start with all this data, and you're trying to find if people have been stealing your data. So you might look at network flow data. This, I think, is what Amazon or Google did to catch China. In the end of 2009, they saw large volumes of data going to China when they did not have a business office in China that should have been getting it. You can look at your logs and see if there's something funny, like we've seen before in my DNS class. If you have a lot of large DNS responses and queries, that implies something screwy is going on because DNS traffic is typically small. And you might have any kind of abnormal activity outside the usual hours, going to funny places, periods of high amounts of data compression or conversion going on, and so on. Modified services, much of things that persist, things that automatically boot up. These are all clues that somebody unauthorized is doing funny stuff on that machine. Yeah?
Can you do zone transfers over UDP?
No, zone transfers, as far as I know, always go over TCP. It's a good question.
Just block TCP.
That was commonly recommended, was to block TCP and only let UDP go out, but DNSSEC ruined it. DNSSEC records are so large that isn't a wise move anymore, which is one of the many reasons a lot of people very much didn't like DNSSEC. But that ship has sailed. DNSSEC is really out there, so you can't block TCP/53 that casually anymore. And so then you're looking for malware. You'll have some leads, you'll have some dates and some location. Then you try to find programs that automatically start, make sure that system binaries haven't been Trojaned, and so on. These are the usual things, virus scans. You look for the normal artifacts of an infection. More normal tech support people are pretty used to this kind of stuff. And then you look for legitimate tools. There is a lot of attackers do not use malware. They just use legitimate system tools. And this is why in our CCDC team, there are people that say you need to download and install something, but the whole point of that is to learn how to just use the normal utilities to protect your system. If you actually know what you're doing, you don't need to add more software. There are tools there that will do everything you need for offense and defense. So that's the game. A lot of people just use normal system tools to do what they're doing, because all you have to do is get a password or something. Then you can get in there the same way normal workers do. So you can look for abnormal user login times, so see if there's some way to automate this. This is why you typically have to know some scripting. Python, Bash, PowerShell, that sort of thing is very useful. So you can easily whip up a script to hunt through some log file and find the pattern of interest, or run some kind of tool on many files and so on. And so you choose your methods, decide what kind of resources to use, and then find a way to do data minimization. This is one of what I used to do at the escrow agency. We did this process called deduping. We would have databases from, a company would get sued saying you ripped off your customers. And so the lawsuit would say you have to give us a list of all your customers and how much money you ripped off so we can give them back some money. And they would give us this garbage. There was typically a huge database with like 10 copies of each person, but their name spelled differently. And we didn't want to mail that person 10 checks, so we had to find the duplicates. And this was not easy. So we had various techniques of hunting for things that were close enough to consider them duplicates. So here are some techniques. External resources will help you. There are a lot of libraries of known files and their hashes, because if you have a known file with the correct hash, then you don't need to bother looking inside that file. It's just a known piece of software like an installer for something, and you can save a lot of time by not bothering with any of those things. Bit9 is another company that does this kind of stuff in the cloud. Just thought it kind of funny they got hacked. But anyway, VirusTotal is of course a standard. Google runs it now, and if you send anything up there, they will scan it for you and tell you if it's a known virus. They will also tell the antivirus companies about it, so it tends to violate your OPSEC. And then there's manual review. You can actually just look at every file in a folder or something if you get down to a small thing to look at. This is where it all started. I remember one of my French teachers said, I started when the only forensic tool was Norton Disk Editor. You just look at the disk in raw hexadecimal and see what's on there. And you can still do that, and you do that in things like malware analysis and when developing an exploit, but you can't really realistically do that for a whole hard drive. But that's how you really get the truth. Just look at the raw hex. And so then you may have thousands of files, and you're going to have to filter and somehow look for this ones that stand out by file name, by date, or something else you can determine about them. And then you do statistical analysis. So you look for server logs, and there are log analysis tools that just try to find ways to visualize it so you can see what stands out. Sawmill is one of the many things you can now plot it different ways. Here's page views by time, so apparently something happened at these particular times that might be important. Maybe this was an attack or something. And then there's the number of visitors. And so you can try to, and then here's the type of devices that are coming in, and you could look for the small categories in each of these and try to see if one of those categories is giving you a clue as to what the exceptional ones are. And you can do strings and keywords. This is how basic computer forensics is done. This is how my teacher taught me to do it years ago. The way you do it, see, in science, in physics, there's a lot of this. There's a problem that is so hard you cannot solve it, and yet you're trying to figure it out. So what you do is you make an approximation, then you make some system to improve the approximation, and you run it until it's not changing anymore, and you call this a stable solution. You don't know it's right, but you do know that you're wasting your time working anymore, so you publish, and off you go. And that's what forensic people do. It's the same thing. You never know you found all the evil on that drive. So what you do is you start with some keywords, like the name of the company that was hacked, the name of the suspect, the name of something relevant. You search for those strings, find things, find more strings, and search again. And when you're not finding anything new, you quit. You're done. There, I found all the evidence that is reasonably obtainable from this disk. I have not looked at every bit, but this is how I've made a reasonable effort to find what's there. And there's no point paying me to do more work because my procedure is not finding anything new anymore. So That's how you do it. Now, there is stuff on the drive that is no longer in use. These are the unallocated blocks at the end of files, which are never complete files. They're fragments of files. And then there's unused bytes at the end of active files, but there's a whole unused blocks of data too, and those might contain complete files. And modern forensic suites will automatically try and sweep up the data there and build files out of it if it can. So they do it with file carving. They just look for headers for images and pings and Word documents and try to figure out if you can find all the leftover blocks of an image and put it up. And so they'll just show you the images, and a bunch of them will be broken. See half the image and then garbage because it wasn't able to really find all of it. But a lot of them are intact enough that you can see them more or less, and same with Word documents and the zip files and everything. Foremost is a very handy tool for this. It's included in Kali Linux. But all the expensive proprietary forensic tools do it automatically. And you can also do string searches in the unallocated space. You might find some readable text even when you only have a small fragment of a file. That's not very likely to be useful. The only real use of that I know is when you're trying to break into something encrypted, you take every string on the hard drive, hoping to actually save the password somewhere. And then even if you find in a fragment, it doesn't matter. You take every possible string and that's your password list. So you got to evaluate your results periodically. You should be reviewing with people to decide whether you're actually going somewhere or if you're just wasting your time doing something pointless. It is very common, this happens to me all the time in capture the flags, that you have some wrong assumption and you're going the wrong way and you're just wasting your time. And it's very helpful to have other people outside who can see that. They'll just forget that tech, they'll try this other track over here, which might get us somewhere. And so I went into the Department of Defense bug bounty program, for example, and I had never used .NET Nuke. I didn't know anybody used .NET Nuke. I thought that was long dead, but that's what they used at the Department of Defense. It is a content management system like WordPress that runs on Microsoft Windows. It is horrible, and that's what they use. And I ran a scanner and got 300 vulns, and I said, holy cow, and I said, oh, no, that can't be right. And it wasn't right. They were all false negatives, false positives from that scanner running on .NET Nuke. It can't be that easy, and it wasn't that easy. But I think one of our guest speakers we had, I think last semester, was here, and he actually won like $100,000 in that bug bounty. So, but mostly bug bounties is very hard to make money in. You'd be better to just get a job. It's like any get-rich-quick scheme. Unless you're really the best in the world, somebody else will have got there first, and you will not get the money. I did make a few $100 in bug bounties, but I'm never fashionable enough to really make a lot of them. All right. Which one of these does not have any user data? Firewall typically wouldn't have any. The rest of these would have files created by users. All right. So which disk format is called expert witness? That's actually the correct name for it. It's E01, not Encase used it, but expert witness, a long dead product, is what made this format. The product died, but their format went on. All right. What do virtual machines use for disks? Yep, VMDK is VMware virtual machines. Microsoft's use VHDs. All right. So which one uses uppercase, lowercase, and numbers? That's base 64, uppercase, lowercase, numbers, and 2 punctuation marks. Add up to 64 total characters. If you use Bitcoin, they use base 58, which is there just to give you a headache. All right. So which technique finds headers and footers to reconstruct images? Okay, that's file carving. All right. And so let me make a note of the winners, and then I need to say something about the project because it is extremely cool. So I tried to give you a new project today, and I thought I had succeeded, and now I'm not so sure. So let me boot it up and I'll show you. I'm trying to give you Alien Vault. Now, Alien Vault has been a SIM for a long time. It's famous, and it just got bought by AT&T. There's a free online cloud-based demo, they say, but it doesn't let me in. It gives you an account. You can't log in. I think AT&T turned it off or something. So that would be a lot better. But what I did was I used the really free version where you have to install it yourself. I said, well, how hard can it be? And the answer is, it's horrible. It's not quite as bad as IBM QRadar.
Is it the extra credits one?
Yes.
Yeah.
And even as extra credit, I'm highly tempted to just take it down because let me show you what happens. All you got to do, let me bring up the project and then I will complain about it. So this So all you have to do is go get the ISO and then boot from it. How hard could that be? So you download this ISO, it's only 700 megs. Then you're going to need to know your IP. You need to have a Windows machine. At least the way I did it, I made it so you put an agent on the Windows machine and you monitor what the Windows machine is doing, which I thought was probably the most reasonable use case. So you have a Windows machine and you have its IP information. That's fine. So now you download the ISO and you boot from it, and you make sure and boot from the CD, and then you get a chance to install Alien Vault. So you install it. Takes about 10 minutes. You answer a lot of silly questions like your language and stuff, which is fine, and it goes on. Okay, then you get this screen and it freezes dead. It won't even finish booting up. And so I Googled, what the hell? And they said, well, you need to give it more resources. So I gave it 4 gigs of RAM and 2 processor cores, and then it came up, and then I started trying to do things on the Windows machine to see what it would do, and all I got was a lot of warnings that said I'm out of RAM. Alien Vault ran out of RAM, system crashing, become unreliable, system unstable. So I gave it 8 gigs of RAM. And then it stayed up for about a half hour and I wrote the project. And when I tried to boot it up again to try something else, it ate up all 8 gigs of RAM and was still going up. So I think it's got a memory leak from hell because I'm not doing anything. I'm just running 2 virtual machines that aren't doing anything, and it's just clogging up the RAM. So I shut it down. So I'm going to show you. We'll see what I got here. So you boot this thing up. It gives you this. This is supposed to finish at some point. And then you're supposed to be, now when it brought up that screen saying it's sniffing my network, I didn't ask it to sniff my network, by the way. There's a deployment mode where it sniffs the live network, and I did not use that mode, so I do not know why it's sniffing the network. This may be related to why it's using up all of my RAM. But anyway, for some ungodly reason, it is sniffing my network. Okay, now it's up. If it does come up, you will see this glorious screen here. Okay, where it shows you your IP address. Go to this IP address and you can control it through the web interface. You could also SSH in, by the way, which is what I had to do. You're not supposed to. They actually want you to explain to them why you think you had to SSH in, because they think it's going to work and you don't have to do that. Ha! Anyway, so if I come in this way, 192, 168, there it is, 10, okay. It's kind of like all these other things that are too cheap to write a GUI. It's a web server, and theoretically, hey, neat, maybe it's just dead. That's the right address. And in the principle, it should answer. Let's see, maybe it's too dead to answer already. And it's not complaining. Well, right. I'll go back to my pictures. That's why I think you might be able to run it for half an hour and finish this project, but then I think it'll self-destruct on you. So once you get it up, you can then prepare your Windows server. Now, here's more good, clean fun. You're supposed to be able to push the agent over onto the server, which I tried, and nothing happens. So then I went to their blog, and their blog does not recognize the existence of 2016 at all, nowhere in the documentation. All they have is 2012. And they tell you, if you want to use it on 2012, you have to adjust the firewall rules and the group policy settings and everything. So I said, well, okay, I'll do all that. I do all that, then push it over until nothing happens. So it says it works, but nothing happens. So that was good, clean fun. So after trying to push the agent over, I gave up, and I said, well, there's another option, which is to download the agent and put it there. So after you go through, this is the wizard of what mode you're going to use it in, and what steps. So you can go through these things, you monitor your network, discover assets, and then collect logs and monitor assets. You go through these steps, which I did. Okay. And by the way, like other open source things, if you forget to give it enough RAM or you only have 1 NIC, you're just screwed. It will just die halfway through without telling you, which is, as far as I can tell, the only point of all these free products is to convince you that it's worth paying for Splunk. Anyway, so once you get in here, you now have an agent on Windows. It scans your network and finds a Windows machine, and you can say that's good. And then you can give it the name and password of the Windows machine so it can push the agent out there, but it won't. And so anyway, once you get up here, you can now manually deploy the Windows agent. So if you go into the right part of this thing, it has information here about the agents, and it has a bunch of meaningless little icons on the right, and one of them will download an agent to put on the Windows. So I did that. You download this thing and install it on the Windows machine, and now it will actually be active, connected to your machine, sending information back to this one. And if you look at the log, you will actually find HID's agent started, Windows audit event. It's actually getting information from the Windows machine now. And then, I also, by the way, have been trying all day, but I cannot find anything you can do that actually makes a security event of any importance. I tried That's what I was doing when the thing died on me. I tried putting on Kane and stealing the password hashes, thinking perhaps it would feel like something was wrong about that. But it just died before I could see whether it considered that significant. So if you create a new administrator account, I would think it would care about that. And it does record it, but as a low privilege event. So you can at least see now user account changed. So you can, I assume there is some kind of horrible thing I could do on my Windows machine that would actually regard as important. But at least this you can see it's working. So I had you turn in a picture of that to show that you got it working. But let me see if I can show you anything live. And here it is. Here, glorious Alien Vault in. So when I log in, we can see the events here live. So now, here's my top 5 alarms. Nothing has been an alarm yet, which I thought downloading the password hashes ought to set off an alarm, but they failed to ask me. So anyway, here's logged events. Here's the top 10 hosts with multiple events, and this is the Windows machine, the yellow one. So you click on that, it'll show you more details about the Windows machine eventually. I'm just going to go to security events here and see if it actually responds or what. And I think it's not complaining, but it's actually moving. Okay, so here's the raw events. Okay, it's not complaining about RAM yet. That's good, because pretty soon all you get is ran out of RAM, I'm dying, please help. But before you get that, it does something resembling actually analyzing stuff. You can even go to real time.
You got a bunch of error codes at the bottom.
Yeah, those might be from the last time it choked and died. Yeah. There we are. Here's login session closed, sudo session closed. That's Alien Vault running on the Linux machine. If you want to see what it's doing on the Windows machine, you can tell it to only give me the HIDS events. So here is the show events data sources HIDS. This should remind you a little bit of Splunk. Specify your data source. So now I would get, as far as I can tell, events mostly from the Windows machine that is being monitored. Querying the database, and there they are. There's my Windows machine in Alien Vault integrity checksum change. That's not very reassuring. Login session expired. Again, I'm not seeing anything from the Windows machine here, actually. And this, well, since it's actually not dying, let's reproduce what I was trying to do before. So here's my Windows machine. And it seemed to me like running Kane and stealing the password hashes ought to be worth a security event. But what do I know? So here I am in Kane. So if I do add to list, next. There, I just stole the password hashes. This would seem important to me, but perhaps not to Alien Vault. So now if I go back to dashboards overview, executive, there are still 0 alarms, and there are suspicious events are not visible. Nope, I think there's not even been a single suspicious event yet. None of this counts at all for some reason. Here's security. Top 10 promiscuous hosts. Here's security events, right? They're all just Alien Vault complaining about itself. Not a single thing. There's nothing wrong with that Windows machine at all. This is perfectly fine. Everyone should be dumping the password hashes every day. That's just fine. I also tried connecting previous ones with Metasploit, take over, get a command shell. They just say, oh, everything's fine, fine. So this is why I guess they pay us the big money. It is not easy to detect these things. The only thing I've seen that actually works is the $1 million IBM product, QRadar. That actually works. It says, hey, somebody just hacked the password hashes. Somebody just came in. That's a interpreter shell. Yeah, yes. What it ought to say. I don't know why. I don't know what the point of this damn thing is. It doesn't, I can just kick in the door and start stealing stuff and it says, oh, everything's fine. It's like the dog that sleeps through the burglar. Anyway, but this is a standard in the industry. People use this. People charge money for it. Apparently there's some way to get some good out of it, but I didn't find it. Anyway, you can turn it on and see it go. And presumably after AT&T is done reconfiguring it, it'll turn into something. So it's extra credit, and God have mercy on you. By the way, I should also mention, the registry stuff is coming up, and I actually made a registry hunt project. This one's actually kind of fun. When we get to the registry chapter, you will suffer because there are like 100 registry keys that matter. And you kind of have to know them. And I made a nice project here where you can hunt for them for extra credit. I have registry image, you can find all these strange things hidden in there. because that's what happens. Malware hides it all over the place. And the Windows registry is just like a whole garage full of junk. There's just tons of places to hide stuff. And finding stuff in the registry is like digging through your garage to find that one thing you had 5 years ago. But you get used to it. So this is a project where you can practice that. Anyway, that's all I wanted to show you. If you do that Splunk if you do the Alien Vault project, you may have enormous difficulty. You need a very powerful machine, and even then, it will just self-destruct before long. Yeah.
Are you going to post the rest of the projects for December in there?
For what?
Like the rest of the projects for the year?
As soon as I can, yes. So far, I'm having enormous trouble writing them.
Oh.
Many of the products I attempt to get working do not actually work worth a damn, like this one. Like I spent like 2 weeks trying to write QRadar in a previous class. There are many products that sound good. When you actually try to use them, you discover that they are not any use unless you have like $1 million. Anyway, so I'll let you know. If I don't find a few more products that work, there just won't be that many projects. All right. Any other questions? All right. Well, that's, by the way, there's this thing tomorrow, this tour.
It's already
full?
It's all, yeah, well, you had to go back and forth with the security folks there.
Okay.
to get in
So
there.
no new people. Okay.
Is there anybody in here who's going? Did you send me a thing saying you're going?
No. Should I?
Or, then you may not be
Your
going.
Visitor pass?
Yes.
Okay. Did you find out the name of the place to go to 2117
Yeah.
Shattuck? Okay. I've been in several classes today.
Yeah.
In every class, there's like 2 people who are signed up and think they're going, but they're like not going.
Yeah.
So. that's
Well,
why
if
I
you
asked,
can't
yeah.
go to that,
Yeah.
go to this. I signed up for this, and I got in threat hunting in the daytime.
That's 11/6.
Yeah, I know. It's before that. This goes on until
okay.
3:30. This is from
Okay.
8:30 to 3:30.
Oh,
Threat hunting
okay.
workshop, which sounds very good, and it's free and it's in San Francisco.
Wow.
So I recommend checking it out. I got in. They had me fill out a form, and I thought they might decide I wasn't important enough, but I got in. So this is Risk IQ, and these other companies are giving you a threat hunting workshop from 8:30 to 3:20. So sounds good.
What's the address?
I think they email it to you when you go here. There it is. There, at Boston College,
Oh,
or
135.
Babson College, Main Street in San
Okay,
Francisco. So, but you can't just show up. You have to pre-register.
Right.
But I registered like right before class, and they let me in. So I guess it's not full. So jump on it. I would say this sounds great. I know the Splunk, Boss of the Sock thing. That was great. The Whisk capture the flag. A lot of these things that go on in here are really good, and you can't beat the price. So, anything else?
Thank you. That's it
Okay.
for now.
All right.
Thank
Good.
you.
Well, that's it for now. I'm just going to clean up and go to the lab and help people. And if nobody needs help, I'll try and get this AI thing working.